So today we will also solve few more problem. Then we'll go to nuclear physics. Okay. So today's lecture is basically based on problem solution. Okay. So first problem is, please write that problem. Okay, please write that problem. The wavelength of K alpha X-ray, the wavelength of K alpha X-ray of molybdenum, its symbol is basically MO, and inside bracket we have to write that atomic number is 42. Okay, the wavelength of K alpha X-ray of molybdenum target is 0.72 angstrom. The wavelength of K alpha X-ray of molybdenum target is 0.72 angstrom. Full stop. Then write, calculate the wavelength of K alpha X-ray for copper target. So you have to calculate the wavelength of K alpha X-ray for copper. You know that atomic number of copper is 29. So for molybdenum target, that wavelength is given lambda equals to 0.772 angstrom. Okay, so I'm repeating, the wavelength of K alpha X-ray of molybdenum target is 0.72 angstrom. Calculate the wavelength of K alpha X-ray for copper target, and the atomic number of molybdenum is Z equals to 42. For copper it is 29. So you know that K alpha, what is the meaning of K alpha, right? So let us solve this. So K alpha means that electron is basically coming from n equals to 2 to n equals to 1. So electron is basically initially at n equals to 2 state. When it is coming to n equals to 1 state, then it will emit the photon, and that photon is basically X-ray when you are using that heavy metal. Okay. So you know that formula, yesterday we have discussed that 1 by lambda, that is nothing but how much? R into, for K series I discussed that screening constant is how much? For K alpha or all K line, that screening constant is basically 1, right? And since it is happening between 1 and 2, then what you have to write? 1 by 1 square minus 1 by 2 square. Is not it? Now for molybdenum, that wavelength is given. Okay, so for both X-ray, that part is constant. Is not it? This is also constant. For both X-ray or both target, K alpha, since it is K alpha, obviously this part will be fixed. R is already fixed. So there is only variation of lambda because of atomic number, and K alpha for all K line, I told you that sigma will be 1. So you can reduce this formula for K alpha, that will be basically 1 by lambda should be proportional to Z minus 1 whole square. So 1 by lambda should be proportional to z minus 1 whole square. Now you know for molybdenum z is you know, lambda you know, then you can calculate these things, right? And for copper target, you know that its atomic number, but you don't know its wavelength. But with the help of this value or data, you can easily calculate. That I will calculate. So we can easily write that lambda of molybdenum will be inversely proportional to 1 by 42 minus 1 whole square, right? And let us assume this is your equation number 1. And you know that lambda of molybdenum, that is given 0.72. And similarly, you can write for lambda of copper or the wavelength of X-ray emitted by copper target, and that will be simply 1 by 29 minus 1 whole square. So let us take this is equation number 2. Okay, you know that lambda of molybdenum that is given as how much? 0.72 angstrom. Is it clear to all? Now let us divide equation 2 by equation 1. If you divide it on the left hand side, you will get lambda of copper divided by lambda of molybdenum should be equals to how much? 42 minus 1 whole square divided by 29 minus 1 whole square. Is it clear to all? Is it clear to all? And you know that lambda of molybdenum, so definitely you will get lambda of copper, and that should be equals to 0.72 times 41 divided by 28 whole square, and obviously that unit will be in angstrom. Is it clear to all? Is it clear to all?
Sir.
Now can you calculate it? Can you calculate?
1.54 times
1.54.
54.
Okay, everybody agreed? Is it? Are you getting like this? Karthik, are you getting? Dhruvi, Anju, yes, are you getting? How much you are getting? So 0.72 into 41 divided by 28 whole square. How much you are getting? So it will be approximately how much? 1.53 angstrom. Is it clear to all? Any doubt? Every people are getting this? So we'll do few more interesting problem. Okay. Shall I proceed? Every people done this? Okay.
Yes, sir.
Okay. Now please write another problem. Yes. Suppose, please write this problem. According to Bohr's theory, the magnetic field produced at the center of nucleus, the magnetic field produced at the center of nucleus due to orbital motion of electron according to Bohr's theory, the magnetic field produced at the center due to orbital motion of electron at nth Bohr orbit Bohr orbit is proportional to, that you have to check. So you know that proportionality that you have to check, that option is given 1 by n square or 1 by n cube, or C is 1 by n to the power 5, D is 1 by n to the power 6. So here n is principal quantum number. N is principal quantum number. So that question I am repeating. According to Bohr's theory, the magnetic field produced at the center due to orbital motion of electron at nth orbit, where n is the principal quantum number. Now, how that magnetic field will be varied with n? N is here principal quantum number. So, is it varied like 1 by n square, or 1 by n cube, or 1 by n to the power 5, or 1 by n to the power 6? That you have to check. So how we'll do this? So you have to solve this question, you have to have some basic idea about electromagnetic theory. So that I will tell you. So you know, when a current carrying loop, suppose you have this loop and it is carrying some current. Current is carrying means there is some flow of charge around this loop. If the radius of this loop is r, then magnetic field produced at the center due to this current flow is how much? You people know that, right? That is nothing but mu naught I divided by 2r. So magnetic field produced due to the flow of current around this loop, so that magnetic field at the center will be mu naught I by 2r, where r is the distance or radius of this loop. Same concept we'll use there. Okay. So what is basically happening? So you have nucleus and electron at nth orbit. For any n, n can be 1, 2, 3, 4. So you keep mu by 2 constant. Now you have I and 1 by r. So you see, let us assume this is your nth orbit and electron is here. So current is nothing but rate of charge flow, right? Current is nothing but rate of charge flow. So that rate of charge flow, let us take any cross section. So this cross section will flow on electron after its time period. So this electron, suppose it is here, so after complete this path, and how much time it will take to complete this path, that is nothing but its time period, that is denoted by capital T. So rate of charge flow at any cross section around this loop will be how much? Simply it will be charge divided by its time period. Okay, and you know time period is for rotational motion is how much? 2 pi r by v. So what I have done, the magnetic field produced at the center of nucleus due to the flow of charge, and the flow of charge is nothing but flow of current, because current is nothing but the movement of charge. So when the charge is moving around this orbit, there will be flow of current, and that current will produce magnetic field at the center of that nucleus. And according to the basic theory of electromagnetic theory, you can say that magnetic field at the center will be mu naught I by 2r. Since mu naught by 2 is constant, we will keep as it is, and current is nothing but rate of charge flow. For circular loop or for this orbit, you can write it E by t, where t is the time period, and 1 by r. Now for rotational motion, you can write t equals to 2 pi r by v. So if you substitute it, you will basically get magnetic field will be how much? Mu naught by 2 into, you can keep E also. Now we will have 2 pi r by v. So v will come in numerator, you will have 2 pi r, and you have 1 by r is there. Now if you remember, in our previous discussion, you can say that r is related to principal quantum number, right? If you remember, Rn was nothing but n square a naught, where n is principal quantum number. And if you remember, v was nothing but inversely proportional to 1 by n. So if you remember that speed and radius is depend on principal quantum number. So definitely the magnetic field will be depend on principal quantum number. So you have this all are constant, mu naught E by 2, 2 pi is constant, but V is varying with principal quantum number, R is also varying with principal quantum number. So you can say V is proportional to V by R square, and V is inversely proportional to N, R is proportional to N square. So you can easily say V will be proportional to V. For V it will be 1 by N, and for R square it will be basically 1 by N square whole square. Is it clear to all? What I am saying, is it clear to all? Is it clear to all?
Yes.
Okay, so you can easily say that V is inversely proportional to n to the power 5. So magnetic field produced due to the orbital motion of electron at nth orbit is inversely proportional to n to the power 5. So magnetic field due to first orbit will be higher than the magnetic field due to second orbit, and you can say that magnetic field due to orbital motion of electron at second orbit will be higher than the third orbit. Is it clear to all? Is it clear to all? Okay. Shall I erase? Shall I erase?
Yes.
Okay. Okay, please write another problem. Okay, please write another problem. Electron in the hydrogen atom, electron in the hydrogen atom, or you can write an electron in the hydrogen atom makes transition from N1 to N2. Where N1 and N2 are principal quantum number. Okay. If the initial time period of electron, or you can write if the time period of revolution of electron in the initial orbit is 8 times the time period of revolution of final orbit, then find the relation between N1 and N2, how they are dependent. So in an electron in the hydrogen atom makes transition from N1 to N2, where N1 and N2 are principal quantum number. if the time period of revolution of electron in initial orbit is 8 times the time period of revolution of final orbit, then calculate the relation between n1 and n2. Okay. So in initial orbit means n1, right? So what is happening? Suppose you have nucleus. Electron initially at n1, okay, and it makes transition to n2. For this initial state, time period of revolution, it means to complete this orbit, it takes time. Let us assume it is t1. And for this orbit, let us assume the time period is t2. So to solve this question, also given that according to data, I can say T1 is 8 times T2. T1 is 8 times T2, right? T1 is 8 times T2. So to solve this, you have to find the relation between N1 and N2. So to solve this question, you have to find the relation between time period and principal quantum number. Same type of question used to ask the relation between frequency of revolution and principal quantum number. So if you know the time period and relation between time period and principal quantum number, you can easily calculate the relation between frequency and principal quantum number, because T is nothing but 1 by F. So let us do or solve this question first. So how will do? You know, T is nothing but, just we have discussed, 2 pi r by V, is not it? And we know that R is varying with principal quantum number as n square and V is varying with 1 by n. So you can easily say from this fellow you will get contribution of n square, and from this fellow you will get contribution of 1 by n. So it is basically, if you make it 1 by n, that n will come to numerator, and you already have R, so R will contribute n square and V will contribute n. So there is a relation between time period and principal quantum number will be T proportional to n cube. So time period for higher state, you can from this equation you can easily say that time period of revolution for higher state will be high, T will be high. So for T1 you can write, for T1 it will be proportional to n1 cube, right? Let us assume this is equation number 1. For second orbit or final orbit, so n1 was the initial orbit. From here electron make transition to n2. So obviously n2 will be your final orbit. So let us assume that time period, or we already have assumed, that is T2, and that is nothing but n2 cube, right? And let us assume this is equation number 2. So if you divide 1 by 2, you will get T1 by T2, and that is simply n1 by n2 cube. Is it clear? The writing is clear here, or shall I repeat? Is it clear? Please reply me. Okay. And from the given data, the T1 is 8 times T2, right? T1 is 8 times T2. So if you substitute it, you will get 8 equals to n1 by n2 cube. Okay. So 8 means 2 cube equals to n1 by n2 cube. So it means n1 equals to twice of N2. So this is the relation between N1 and N2. Is it clear to all? Is it clear to everybody? Is it clear? Okay. So if there is a relation between T and N like that, then how the frequency will depend on principal quantum number? How the frequency will depend? So just now we have derived that T is proportional to N cube. So we know T is inversely proportional to frequency, right? Or T is nothing but 1 by F. So it means if T is proportional to N cube, obviously frequency of revolution is inversely proportional to 1 by N cube. Is it clear to all? Shall I proceed? Okay. Next problem, please write that problem. Calculate the ratio of minimum wavelength of Lyman and Balmer series. Calculate the ratio of minimum wavelength of Lyman and Balmer series. Okay. So we know that 1 by lambda equals to R into 1 by NF square by 1 by NI square. For minimum wavelength, N will be how much? Ni will be how much? So this is your final state principal quantum number. This is initial. So I already discussed the minimum wavelength means the energy gap is high. So initial state and final state, that energy is large. So for minimum wavelength, that Ni is how much? Infinity. Is not it? For minimum wavelength, the Ni should be, or initial principal quantum number should be infinity. So it means 1 by lambda mean is nothing but R by NF square. And for Lyman series, you know that NF. For Lyman series, NF is how much? For Lyman series, NF is 1, right? So obviously that 1 by lambda mean, let us assume take that one subscript, that is 1, that corresponds to Lyman series, that will be simply R, right? Is not it? So you can say that lambda mean 1 should be equals to 1 by R. Is it clear to all? So lambda mean 1 means the minimum wavelength of Lyman series, and that should be equals to 1 by R for hydrogen atom. Okay. Similarly, for Balmer line or Balmer series, let us take that number 1 by lambda mean subscript 2, and that should be equals to, now NF will be 2, right? So R by 2 square means simply R by 4 for hydrogen atom. And let us assume this is your equation number 2. So you have to calculate. So from here you can easily get lambda mean 2, we'll assume later, 2 will be nothing but 4 by r. And now let us assume it is equation number 2. Now if you divide equation 1 by 2, you will get lambda mean 1 by lambda mean 2, and that should be equals to 1 by r divided by 4 by r, and that is r will be cancelled, that is nothing but 1 by 4, right, and that will provide you 0.25, that will provide you 0.25. Is it clear to all? The ratio of minimum wavelength of Lyman series to that of minimum wavelength of Balmer series for hydrogen atom is 0.25. Is it clear to all?
Yes, sir.
Okay. Shall I proceed? Okay. One more problem, please do. The potential difference across X-ray tube is 20 kilovolt. The potential difference across X-ray tube is 20 kilovolt. Calculate the minimum wavelength of continuous X-ray. The potential difference across X-ray tube is 20 kilovolt. Calculate the minimum wavelength of continuous X-ray. It is very easy, right? Is not it? It is very easy, right? So how we'll do? If you remember yesterday, last time we have discussed that lambda mean or minimum wavelength of continuous X-ray is nothing but Hc by EV, where V is the applied voltage. Is not it? So just I'll substitute V here, that is 20 kilovolt. So if you substitute all number here, H is 6.6 into 10 to the power minus 34. Then you have C is 3 into 10 to the power 8 meter per second. E is on electronic charge 1.6 into 10 to the power minus 19. Then V is 20 kilovolt, it means 20 into 10 to the power 3 volt. Is it clear to all?
Yes, sir.
Now if you calculate, how much you will get? If you calculate it, how much you will get? You will get approximately 0.62 angstrom. The minimum wavelength of X-ray will be 0.62 angstrom. Shall I erase? Next problem, please write that next problem. Calculate the magnetic moment produced by electron that is rotating in the nth orbit of hydrogen atom. So what you have to calculate? Calculate the magnetic moment produced by electron due to its orbital motion at the nth orbit of hydrogen atom, where n is the principal quantum number. Calculate the magnetic moment that is produced due to orbital motion of electron at nth orbit of hydrogen atom. Can you able to do it?
Yes.
How will do? How will do? We know, suppose you have current carrying loop, it is carrying current. The orbital motion means motion of charged particle around nucleus, and motion of charged particle will produce current. So due to this current, you will have some magnetic moment. So suppose you have on loop, its radius is smaller, then magnetic moment due to that flow of current I is nothing but I into A, where A is the area of that loop. So here M means magnetic moment, and A is basically area of the loop. Since the loop is circular in nature, so you can basically say the magnetic moment will be simply I into area. Area is nothing but pi into r square, right? Is it clear? Area is nothing but pi into r square, right? Now, you know, just now we have defined that I is nothing but E by T. So it should be E by T into pi r square. And also we have defined that T is nothing but 2 pi r by V. And that should be equals to, sorry, should be multiplied by pi r square. That should be multiplied by pi r square. Okay. So if we do it calculation, pi will be cancelled, on r will be cancelled. So you will end up with getting EVR by 2. EVR by 2. Now if you multiply ME and divide by ME, and if you bring that ME here, then you will have MEVR. MVR means orbital angular momentum. So if you bring this ME here, you will get MVR. MVR is nothing but orbital angular momentum. So you will end up with getting E by 2ME, and you have multiplied factor, that is orbital angular momentum. And you know that orbital angular momentum for nth orbit, that is nothing but NH cut, right? So that magnetic moment is nothing but, or this is electronic magnetic moment, you can say. That magnetic moment is originating due to the motion of electron, and that is nothing but E by 2ME, and since it is orbiting at nth orbit, then angular momentum should be NH cut. Okay? Is it clear to all? Is it clear to all? Is it clear? Shekhar? Is it clear?
Yes, sir.
Okay. So it means that magnetic moment will be how much? EH cut by 2ME, into n. And EH cut by 2me is known as Bohr magneton, right? EH cut by 2me is nothing but Bohr magneton, right? So basically you will get, and it is denoted by mu b into n. So for ground state or for n equals to 1, that magnetic moment will be how much? Simply mu b. Is it clear? Is it clear to all what I am saying? That the magnetic moment due to nth orbital motion is n into mu v. For ground state, that n value is on, right? So for ground state, for n equals to 1, magnetic moment will be how much? Simply mu v. Is it clear? Is it clear? Okay. Now we'll do one more problem. If you will finish that problem.
Yes, sir.
Okay. Please write another problem. Yes. So suppose in the hydrogen atom, suppose in the hydrogen atom, electron at initially at n equals to 3. Initially electron is here. So how many emission line you will get? So electron is basically make transition to lower state and you will get photon. So when the electron at n equals to 3, then how many emission line you will get? Anyone? Anyone in the class? Shekhar, how many line you will get? Can you tell me? Karthik, Dhruvi, Anju, anyone?
2.
2. Okay. Any more answer? Anyone? Others? Shekhar, how many line you will get? Initially electron at n equals to 3. 3, right? Very good. So how will get 3 lines? Suppose electron is emitting from make transition from n equals to, this is your n equals to 1 and this is your n equals to 2. So when that electron will make transition from n equals to 3 to n equals to 1, you will get sorry, you will get one photon. It will have some energy or some frequency. It can make transition from here to here, right? Then you will get another energetic photon. It will have some different wavelength or frequency, because this energy gap is the energy of this photon. Okay, this energy gap is the basically energy of this photon. So since these gaps are different, so they will have different wavelength. Another possibility, when that electron is coming here, so it can make transition from n equals to 2 to n equals to 1. So you will have another photon. So you will get 3 emission line. In general, for any hydrogen-like atom, if electron at initially at nth level, you will get how many line? Number of line will be, if people learn this thing in 12th class, number of lines will be how much? Shekhar, can you please tell me? Dhruvi? So it will be basically n into n minus 1 by 2. So for this problem, n was how much? 3, right? So if you substitute 3 here, so 3 into 2 by 2. So it will basically, it will be 3. Now problem will become, suppose they have given that initial electron at n equals to 5. Please do this problem. So initially electron at n equals to 5. Now how many number of line you will get? Now how many number of line you will get? 10, right? Is not it? So basically, if initially electron at n equals to 5, that number of line will be 5 into 4 by 2. So it will be basically 10, right? Is not it? Now we'll do one beautiful problem, that is the end of atomic physics. Okay. Then from tomorrow we'll discuss about that nuclear physics. But before that, please do that problem and please write that problem. Hydrogen a hydrogen atom, please write that problem. A hydrogen atom is in ground state. A hydrogen atom is in ground state and it is colliding with an electron. A hydrogen atom is in ground state and it is colliding with an electron having kinetic energy 13.322 electron volt. Calculate the maximum factor by which the radius of hydrogen atom can increase. A hydrogen atom at ground state is in ground state and it is colliding with an electron having kinetic energy 13.322 electron volt. Calculate the maximum factor by which the radius of hydrogen atom can increase. So if we draw that picture, it will be clear to all. So you have hydrogen atom. So proton is sitting here and electron is initially at ground state, means at n equals to 1. Here n equals to 1. So it will have some energy, kinetic energy will be how much? Sorry, energy will be how much? Minus 13.6 electron volt. And electron is coming having kinetic energy is how much? 13.322 electron volt, and it is colliding with this electron. So maximum energy that can give this electron can give to this will be how much? It will be its kinetic energy, right? That is the maximum possibility. That maximum energy this fellow can give to donate to this, that will be 13.322 electron volt. Is not it? So initially it was in ground state. So after absorbing this energy, it will no longer be in ground state. Is not it? Is it clear to all? Is it clear what I am saying?
Yes.
So now if that maximum energy that electron can have, how much? So Emax can be how much? Simply is ground state energy 13.6 plus this, right? Is it clear? So this is the maximum energy that this orbiting electron can have. Now can you calculate this, how much it will be? Anyone, can you calculate? Can you calculate how much you are getting?
Minus 2.78.
Minus 0.278 or 2.78?
Minus 0.278.
Every people are getting this? Dhruvi, Anju, are you getting this?
Yes, sir.
Karthik, are you getting? So basically you are getting minus 0.278. Is not it? It is in electron volt. Is it? Now can you check this number corresponds to which orbital? Because you know the energy of nth orbital is minus 13.6 by n square. Okay. So if you calculate this, if you substitute this value here, you will get n value will be how much? Anyone? If you substitute, so this is the energy of this electron. So this energy corresponds to which orbit, that you have to check. Then how will check? Just you have to substitute that you have to write that nth energy expression minus 13.6 by n square, and you have to substitute this or keep this value as minus 0.278. If you do this, you will get n equals to 7. You will have n equals to plus minus 7, but minus 7 is not allowed. So you will get n equals to 7. So initially when it was in ground state, it has radius a0. Now the maximum possibility or maximum radius can be corresponds to n equals to 7. So radius will be increased by how much factor? Anyone? Anyone?
49.
Good, very good. Because Rn is nothing but n square a0. Now you have n is how much? 7. So that maximum increase or maximum radius can be 49 times a0. So initially it was a0, now 49 a0. So maximum factor can be 49. Is it clear to all? Is it clear to all? Okay. So I should stop here. From tomorrow onwards, we'll discuss about that nuclear physics. If you have doubt, please ask me. Meanwhile, you will have on test, okay, based on atomic physics, whatever we have discussed. Is there any doubt? If you have doubt on atomic physics, please ask me, because from next class we'll have nuclear physics discussion. If you don't have any question, then I should stop here.
Sir,
Yes.
in earlier question we discussed about magnetic field. So is there any dependence on electric field and radius?
You tell me. So yes, there is definitely there is a relation between electric field and radius, right? You know, when suppose you have charge here, okay, you have charge here, so electric field at this place will be how much? This radius is how much? R, right? So you know, suppose you have charge some charge here, at R distance it will be how much? Electric field will be how much? Will be vary like 1 by R square. Electric field will be vary like 1 by R square. Did you get what? But I appreciate your question. That's a really good question. That's a really good question. Very good. So you know, every people is what she is asking. Since we have derived the relation between magnetic field and radius, and we observed that magnetic field is inversely proportional to 1 by n to the power 5, where n is the principal quantum number. So is there any relation between electric field and that quantum number? She is asking, and really is a good question. I read many books, but no books discuss this. But it's a really good question. But you know, when a charged particle is somewhere and at r distance away, the electric field is simply 1 by 4 pi epsilon naught q by r square. Is not it? So for this case, since you are discussing at the center, so the distance is from charge to this is r, and the charge is here electron. Okay. Now you can easily calculate, because you already know that r is proportional to n square, so E should be proportional to 1 by how much? Anyone?
R square.
r square, and r is related to principal quantum number, right? N square, right? So it should be 1 by n to the power 4. Is it clear? That you were asking, right?
Yes, sir.
Because E is proportional to 1 by r square. So definitely, and you know r proportional to n square. So E is inversely proportional to n to the power 4. Is there any more question? Is there any more question?
No, sir.
Okay. If no, then I should stop here. Okay.
Yes, sir.
Okay. Bye all. Huh?